In this episode of ScopeTrader, we look into why astrophotographers call Starlight data and explain why astrophotography is both science and art.
Each image we take is a record of photon counts, tiny particles of light that have travelled across space for hundreds or even thousands of years before hitting the camera sensor. These aren't just photos, they're scientific data. Each pixel is a number, a measured intensity of light. When we stack exposures, we're not just making a photo look better, we're reducing noise and improving the signal so we can see what's really there. To collect this kind of data, we use long exposures, sometimes 5 minutes at a time or more, because deep sky objects like galaxies and nebulas are incredibly faint. Our eyes can't gather enough light to see them clearly in real time, but a digital sensor acts like a bucket, collecting photons over time. And because every camera introduces some random noise, we take multiple exposures and stack them together. That process averages out the noise and boosts the real signal, bringing out the true structure of a nebula or the delicate arms of a galaxy. This is where the term signal-to-noise ratio, or SNR, comes in. The signal is the real celestial light we want. The noise is the unwanted interference. When we take 10, 20, or even 100 exposures and stack them, we're doing something very similar to what scientists do in a lab, repeating the measurement to isolate the truth. Stacking doesn't add anything fake. It reveals what was always there, hidden beneath the noise. And we don't stop at stacking. We also take calibration frames, dark frames to map sensor noise, flat frames to correct vignetting and dust shadows, and bias frames to measure read noise. When all of this is combined and processed, we create what's known as an integration, a cleaned-up, high-quality dataset that accurately represents the light from our target. But that integrated image is still raw. It usually looks dim, grey, and flat. So the next step is processing. We apply non-linear stretches to reveal faint structures and make interpretive decisions about brightness, contrast, and colour. This is where the art comes in. Even when we assign colours, especially when using narrowband filters like H-alpha, OEE, and SII, we're still visualising real data. The colours might be mapped for clarity, not realism, but they accurately represent different types of light emitted by different elements in space. It's similar to how NASA processes Hubble or James Webb images. They use colour to translate invisible wavelengths into something we can perceive. It's not fake, it's data made visible. You know, in other sciences like biology or geology, this kind of visual translation is pretty common. Fluorescent microscopy or infrared satellite maps use color coding to show things we couldn't see otherwise. Astrophotography follows the same principle. It's data visualization with beauty as a bonus. So, is it accurate to call our images data? Absolutely. From subframes to stacked integrations, every part of the process is rooted in real measurement. That said, when we present our final processed images, especially the colourful, stylized ones, it's also fair to say we're blending science with creativity. Astrophotographers are both observers and interpreters. We collect photons like scientists and process them like artists. What we end up with is something extraordinary, a truthful visualization of the universe that our eyes alone could never see. To read the full article, head over to ScopeTrader.com or click the link in the video description. And if you found this breakdown helpful, please like, subscribe, and share this video. It helps us reach more astrophotographers, image processors, and anyone passionate about turning Starlight into stories.